Okay, so the first thing we're going to do is we're going to describe what an equivalent ratio is. Equivalent ratios are ratios that make the same comparison. Oh, no, that is not going to work. There we go. Tape diagrams. Now, a tape diagram, that is a model, and that's what you use. This is one thing you can use to show equivalent ratios. So a tape diagram uses one bar, and you're going to see what this looks like in a second. It uses one bar to represent one quantity in a ratio. And it uses a second bar to represent the other quantity. So if you think about like fraction bars, like whenever you were learning fractions for the first time, sometimes it would be like a big rectangle and it would break it up. So it's kind of similar to that. We call it a tape diagram. So it's going to look very similar. You'll see it below if you are kind of curious what that looks like. The second type of model that we're going to look at to do equivalent ratios is called a double number line, and it's basically two number lines on top of each other. So the definition, a number line on top to represent one quantity and a number line on bottom to represent the other. The tick marks align to show equivalent ratios. So on a number line, you have those little bitty hash marks. We call them tick marks. So those are going to represent those equivalent ratios. Okay, so let's look and see what a tape diagram is going to look like. My problem says a camera recorded 4 pygmy rabbits and 1 long-tailed weasel. What is the ratio of pygmy rabbits to long-tailed weasels? So the first tape diagram, notice it's broken up into 4 parts. What is that representing?
The pygmy rabbits.
The pygmy rabbits, because it tells me there are 4 of them. So I'm just going to go ahead and label PR, so I know that that tape diagram is a pygmy rabbit. The other one underneath is representing the what?
Long-tailed weasel.
The long-tailed weasel. Okay, so we're going to come down here. I know what each one is representing, but it says over a longer period of time, the camera recorded 3 long-tailed weasels. The ratio of pygmy rabbits to long-tailed weasels stays equivalent to that original 4-to-1 ratio. So the first thing that we labeled was showing the 4-to-1 ratio that it originally told me. Okay, the ratio is staying the same, but over a longer period of time, we now have 3 long-tailed weasels. So what this is showing is this one box for the long-tailed weasel is now representing not just 1, but how much? 3, because there are 3 long-tailed weasels. Okay, so if each little box now up here, they all represented 1. Okay, because I have a total of 4 to 1. So if this one now is worth 3, what does that mean each of these are also worth? 3. So that means that my pygmy rabbits
12.
are now going to be, yes, 12. So to answer the question at the bottom, how many pygmy rabbits did the camera record? That would be 12. Did y'all see how that works?
That's easy.
Okay. You will see this randomly, occasionally. There's not going to be a ton where you have to draw the model or something like that, but you just need to understand what it's showing you. So like NWEA next week, if you have a question like this, you would at least know like what it's talking about. When we're talking about ratios and a tape diagram, you're going to know that this is what it's talking about. Yes? No, you can't. I'm sorry. I know. I don't think it's fair. I think you should be able to use resources, but that's okay.
It's hard enough as
All right. It is challenging, that's for sure. And I know y'all get real challenging questions on there. Okay. The next one says the ratio of pink roses to yellow roses in a flower arrangement is 5-3. Construct a tape diagram to show how many total flowers are in the arrangement if there are 15 yellow roses. Okay. So first of all, I need to draw. So I'm going to make my own. I need to draw 5 boxes to represent pink roses, and I would need how many to represent yellow? 3. Okay, so I'm going to do something kind of like what I just had over there. I'm going to draw a long rectangle. I'm going to break it up into 5 equal-ish parts. And this is my pink. And I'm going to do the same thing for yellow, but I only need 3 of those. Okay. Each box, because it tells me in that second part of my example, it says I want to make a tape diagram to show how many total flowers are in the arrangement if there are 15 yellow roses. So I've only got 3 boxes because my ratio is saying 3 for yellow. So what does that mean each box is going to have to be worth?
5.
They're each going to have to be 5 because I need a total of 15 yellow roses. Well, if I'm trying to figure out, I know that each of those yellow rose boxes is 5. If I need to figure out how many total roses I have between pink and yellow, what are the other boxes going to be equal to? Milo? 5 also. So each of these will also have to be 5. So that means I have how many pink roses? 25 pink. I have 15 yellow. So altogether I have 40 total flowers. Okay, that's my tape diagrams. Now we're going to look at a double number line. Y'all see okay, I want you to just for a second pretend like, let me see if I can, pretend like this bottom one is not here, okay? So now it looks like just like a regular number line, right? Okay, those tick marks just label what we're counting by. So okay. When I remove this, I now have 2 number lines, and I have my equivalent, I have my ratios marked on each tick mark, okay? So again, the definition says the tick marks align to show equivalent ratios. So they're all lined up to show their equivalency. A double number line looks kind of like a table, just without it. Like normally with a table, you would put the numbers inside the boxes. It's similar to a table because a table aligns all of your numbers up and has everything nice and neat and lined up. Here, it's just on the actual tick marks instead of in the boxes. Okay, so it's kind of like a table, but not exactly. So what this is telling me is that for every, look at what I'm comparing, number of couches and number of hours over here on the side. For every 2 hours, 5 couches are moved. That's my original ratio right here. So if I'm trying to predict how many couches could be moved in 36 hours,
90.
Notice what my pattern is down here. Like, how am I increasing each time? What am I doing? I have to multiply 2 by 18 to get to 36. So you have to find that pattern to get from like here to here. Here I did from 2 to 4, I multiplied by 2. They skipped a whole bunch in between. Then they went to 18 and then to 36. So how do I get from 18 to 36? I times 2. So that means I have to times 2 up here. It's kind of like equivalent fractions. Whatever you do to one, you have to do to the other. So that missing number
90.
is going to be 90 couches. I didn't fill in my blanks down there. To predict how many couches can be moved in 36 hours, I got to multiply 2 by 18. Then I multiply 5 by 18. And you get 90. Or you can just go from 45 times 2 and 18 times 2. You find that smaller relationship. So what this is showing down here is that I would take 2 times what to get 36? 2 times 18, that's where this comes from. And then 5 times 18 to get this number. Okay, so you can start with your original ratio, or you can find a pattern within it to continue along in your table, okay? A couple different ways to do it. You might see it, you might not. I just wanted you to have an example in your journal completed so that you knew what it was if you happen to see it. Okay, we're gonna go on to the next part, which is ratio tables. So similar to a double number line, except for now we're putting it into a table and it's a lot nicer. You're going to see a lot more of these. So these are important, and this is what your practice is on today. Ratio tables a lot of times can also be turned into a graph. So you can graph ratios also, but you've got to understand how the table works first. So the definition that we're going to start with is a table of equivalent ratios between two related quantities. A table of equivalent ratios between two related quantities. In a ratio table, each ratio will always be equivalent. They will always increase by the same pattern. So just like that double number line, they were all equal. They were like equal fractions. If you put them all in fraction form, they would all be equivalent to the same thing, okay? Okay, so we have two examples. The first one is talking about brownies, and it says for every 1 box of brownies, I need 2 eggs. So down here in my table, I'm gonna start with the ratio that I know. What would I put on the top row? 1 box requires 2 eggs. Everybody with me so far? Okay. So as the number of boxes increase by 1, and then we're going to fill this in a second, the number of eggs will increase by 2. So let's go ahead and fill in the rest of our table. So if I have 2 boxes, I now need 4 eggs. If I have 3 boxes, I need 6 eggs. Y'all see what's happening?
Times 2.
It's a pattern, okay? That's what a ratio table is. It's just comparing those equivalent ratios, and it's showing you, okay, if I know 1 box needs 2 eggs, well, this is easy. If I make 4 boxes, I need 8 eggs, okay? The next example, I'm gonna let y'all try that one with your groups. It's about pygmy rabbits again. So try that one, and then we'll check it together. Okay, what do we know? What's it tell me in the very first sentence? For every 2 square miles, there are what? 7 pygmy rabbits. Okay, so that's my very first ratio here. So if I, for every 2, have 7, okay, what does that mean I'm going to have to do to figure out this number here? Okay, I want to ignore this for now, and I'm just going to focus on what I'm looking at right here. So I got to figure out, what do I multiply by 2 to get to 6? What is it, Woogie?
So you do 2 times 6 divided by 2 equals 3.
Okay.
So you do 7 times 3 to get 21.
Exactly. Very good. Okay, so you've got to find that relationship. This is what your practice is going to look like today. It's going to be something like this, where you have to find the missing number. So you've got to find that relationship. What am I doing from here to get to here? Here, I know I'm just timesing 3. But Woogie, if you have bigger numbers, you can work backwards. And you can say, well, 6 divided by 2 is 3, so I know I have to multiply 7 times 3 to get my missing number. Okay, here's the next one. So let's look at my original again, 2, where I have it circled in red. What do I do to 2 to get 10? Yes.
Multiply by 5.
I multiply by 5, so then 7 times 5 would be 35. And then the last one, what do I do to 2, my original ratio? Oops. Yep, I times it by 10 to get 20. So 7 times 10 would be 70. Do y'all see how that relationship works? Your original. You go back to your original. Figure out what am I doing to my original ratio to get the next number.
This is a piece of
Okay?
cookie.